Hello, thank you for joining me for building a strong foundation for data analysis. This is a non-technical talk on the organizational requirements for creating a culture that embraces data and values the work and processes that go into identifying the important information for your industry or company. My name is Leslie Andrews, and I am a senior consultant at 3Cloud Solutions, formerly of Pragmatic Work Consulting. I'm a graduate of the University of New Mexico. I currently hold 2 Azure certifications. I spoke at 8 SQL Saturdays in 2018 and 11 in 2019 as an Idera Ace. I competed in Speaker Idol at Summit in 2018 and 2019, and I'm speaking at Summit next week in the Becoming a Data Engineer Learning Pathways section. You can find me on Twitter and LinkedIn at landrews5807. When it comes to converting data into information, the pinnacle is to get to using machine learning, predictive analytics, and the ultimate goal, AI, artificial intelligence. In August of 2017, Monica Ragati, who was a data scientist at LinkedIn and the vice president of data at Jawbone, she's currently an AI and data science advisor, she blogged about the data science hierarchy of needs, where the pinnacle is AI and deep learning. But before you can do there, you have to have the learning and optimization of the data. You have to be able to produce simple machine learning algorithms, perhaps with Databricks, and do some experimentation. But before you can do that, you have to have training data, clean sets with well-defined aggregates and metrics. And prior to that, you have to explore those data sets. You have to find the bad data because you know it's there. You have to prep the data sets. But wait, there's more. You have to have reliable data flow infrastructure, like Data Factory, to move the data. Do you have structured or unstructured data? Should it go in a SQL database or a Cosmos DB? And finally, the first thing you have to do is collect the data from your transactional systems, IoT devices, external data sources. So we can think of AI as the top of a pyramid of needs. Self-actualization is great, but first you need food, water, and shelter. So what are those foundational activities that are required to transform data into information? Here's a graphic from a blog post I found on Dataversity. And these are all of the database activities required to turn data into information, some of them. This section here is database administration, and these things are required regardless of what database is used for. So we're kind of going to ignore that. The rest of these are the bottom 3 parts of the pyramid, the bottom half. And this one section is the top 3. Think about that. All of the work that has to go into collecting, cleansing, and prepping the data before you even get to the gravy, to the good stuff. We have data governance, knowing what the data is and where it comes from, metadata, the data lifecycle management processes. We have our data warehouse and our BI, where you have to know extract, transform, and load processes, at least 2 different types of database modeling. Add in NoSQL database modeling to that, and you've got even more. The learning and the implementing of the business rules, creating cubes for our analysis. Data quality management, what conversions may have to happen, finding duplicates. There's an entire industry devoted to trying to find duplicate people and systems. Data architecture at the enterprise level, being able to cross departments and have a unified approach to data collections and integrations. Unstructured data, where are you going to store all of the image and file videos? How long? Who will have access to that information? Where are you going to back it up? Do your backups work? Recovery, that's an important step that a lot of people miss. You have to understand the transactional processing, more database modeling, understanding vendor data schemas and being able to write queries against what might be challenging data models, optimizing those queries to minimize impact to those transactional systems. And finally, creating the dashboards and reports, historical reporting, data mining, the goal of all of the work that we had to do to create the magic. I like to compare it to those touchless faucets. You stick your hands out and the water magically appears. But how often do you think of all the work behind the walls and under the ground that went into making that happen? The same with data. People think that you just turn it on and clean, usable data comes flowing out, but there is a lot of work that goes into creating that illusion. And that work comes from a team of people. Data science is a team sport. You have all these people that are important pieces of those processes we just talked about. Data scientists, data engineers, we have machine learning algorithms, creating the ETL processes, business leaders to be within the organizations that are our cheerleaders and to be the support at our management level. You need managers and worker bees to share the everyday workarounds they have to do in order to fix the data before they can start to do analysis. And the data visualizers, those artists that create reports and dashboards that answer the burning questions you have about your business or customers. And once you have built your team, how do you win? What do? You have competitive advantages that allow you to make better decisions. So now we're going to do a deep dive into some of the topics in our process puzzle. First up, dimensional modeling. A standard process for an ETL is to have a transactional system that feeds to a third normal form database, if you're lucky, an ETL process that extracts that data and transforms it into a dimensional model, which is then the source for your reporting. We're going to talk about dimensional modeling and how that works and what it is. The purpose of the dimensional model is to report the measurements of your business. It has a low volume of transactions because the database is usually loaded on a timed basis, usually daily, overnight, or outside of your normal business hours when those transactional systems are not in use. It supports the slicing and dicing of the data, which everybody wants to be able to do. This model was created by Ralph Kimball and is considered the standard for data warehousing models and visualization tools like Power BI and Tableau. The standard dimensional model, or star schema as it's also known, has two types of tables in it, fact tables and dimensions. A dimension table stores attributes or dimensions that describe the objects in a fact table. There are different ways to store those attributes, and so we have tables that define the way the attributes are stored or what kind of attributes they are. So a slowly changing dimension is one that, depending on the business requirements, should a history be preserved. And there are type 1 and type 2 changes that we track. This is a part of your design when you're creating your data warehouse, whether or not the information needs to be tracked over time. If your customer moves from one region to another, you create a new record and you have information in there that shows the begin and end date of when those records were valid, so that you have a time change of a customer over time. A rapidly changing dimension is one that changes rapidly. Same thing as slowly changing, it just happens more frequently. A degenerate dimension is where the attribute is actually stored in the fact table, not in a separate dimension table. And this might be something like a purchase order number or an invoice number, something that users really like to have and know about a transaction that may not necessarily be an attribute that you're ever going to be doing any analysis by. We have role-playing dimensions where the same dimension key is joined to multiple fields in the fact table. So if you have order date and ship date, those are types of role-playing dimensions because you have two dates that are connected to the same date dimension. A shrunken dimension, also known as a snowflake, is when you've normalized your dimension. You've broken out a piece of it, say a zip code or state from the addresses. Static dimension is where the attributes are not coming from a data source. So things like your customer address, you're going to get that information on a daily basis out of your source system. A static dimension is one that you pre-fill, preload, it never changes, and it doesn't get information out of those transactional systems. A junk dimensions, just like your junk drawer at home, a whole bunch of dimensions that aren't really related, but you have to have. An inferred dimension is when you use a surrogate key when the dimension isn't ready. For instance, ship date. You have the order date and the ship date. You're going to have an inferred key in your ship date to avoid having nulls in your data warehouse, and that would be an inferred because you put that blank surrogate key in there, like -1 or something. And then a conformed dimension is when you have a single dimension like a date or a product that's used in various tables and reports and at the enterprise level. Then we have our fact tables. The only things that are in fact tables are foreign keys to your dimensions and measures. There are 3 types of measures. Additive measures can be summed across all dimensions. So if you take something like a sales scenario where you're selling stuff at like a grocery store, it can be summed across all of the dimensions to get daily, weekly, monthly, annual sales. It can be summed across the store dimension to get sales by store. A semi-additive measure can be summed across some dimensions, but not all. If you think about your checking or savings account balance at the end of the month, the bank is very interested in having those. But if you were to add up my end of month balances across the customer dimension, that's not going to equal any amount of money I've ever had. I may have liked to have had that much money at some point, but I've never had that much money. That was the sum of all of the balances on the end of the month. It's good for determining all of the funds available at a branch level, maybe for the credit union, but not necessarily at the customer level. And then there are non-additive dimensions where you may have calculations like ratios or percentages, and adding them up is nonsensical. You're just not going to do those types of things. The other thing to know about fact tables is the granularity, which defines the level of detail for a particular event. If we go back to our sale scenario, you might have the fact being the sale, not necessarily broken down by product. So you're going to have a sales transaction, and it's going to have a total of products sold amount, and it's going to have a sales tax collected amount, and it's going to have the total of the sale. So those are multiple measures in a single record at the different grain. So we have at the same grain, we have a single sale, 3 different values. And when we add those up, we can get information about how much tax we owe, what percentage of our sales came in different time periods. We can have multiple measures in a single fact table. We can roll things up. Maybe we only want to know by month. So we're going to have another table that aggregates our sales by month by store, so that when it comes time to do our reporting, we've already pre-aggregated that, and it's faster for our reports to get done. So when you're all done and you have a star schema, this is what that will look like. You have a product sales fact table in the middle. We have our sales amount, which is the measure that we're capturing. And then we have foreign keys to our dimension tables. We have 3 descriptor fields in our product dimension, and this is where we've denormalized in a third normal form for a transactional system. The product description would be in the product table, the product category description would be in the product category table, and the subcategory description would be in the subcategory. And you'd have to join into 3 tables to be able to get all of those in a single query result. And the power of the star schema is the fact that you are never more than a single join away from all the dimensions. Anything you want to know about your sales. Dimensions are designed to be very wide tables. Your date dimension, this is a small subset. Most date dimensions have probably 30 or 40 different fields about the date. What day of the year it was, what day and week it is, what Julian date it is, what quarter it is. Anything that you need to know about the date in order to do the slicing and dicing and the analysis when we get into the reporting. Steve Hoberman, I think he's on the 2nd version of this book now, Data Modeling Made Simple, a Practical Guide. It is a set of techniques and activities that enables us to capture the structure and operations of an organization. The process requires many skills such as listening ability, courage to ask lots of questions, and even patience. I heard the question or the saying, ask why 5 times, right? That's what this is all about. We have to dig in deep and get into our users with the work that they do and be able to structure our data warehouse so that we can answer the questions that they need answered. So when we look at the history of data warehouse designing, the first thing that most companies tried was a data-driven analysis. Let's look at the data we have and combine it and store it. So someone like me or you would go into a small dark office and work furiously for months and come out and be surprised that no one liked the warehouse, because it really didn't change anything. So then we decided that we would go and look at the reports that our users use, and we're going to go and reproduce them. So again, go back into our small dark office and work furiously to migrate all that needed data for those reports and reproduce them. But again, nothing changed. We were using the same data in the same way. So when I started working at the Albuquerque Police Department a few years ago, I was going to build a brand new data warehouse. And at the time, I was a certified Scrum Master. So I Googled Agile data warehousing, and this was the book that came up. Lawrence Core has come up with a way to go from the whiteboard to a star schema with a collaborative approach with our users. So you start by defining an event. You describe the event using the 7 W's: who, what, when, where, how many, why, and how. And then you create data stories. And these will allow you to identify those things that you're interested in knowing about your business to answer the questions that will help you get benefit from your data. It starts off with talking with your users about an event, in this one, a customer order. You use spreadsheets because that's what our users are comfortable with. And you sit down with them and you ask them questions about your data. Who orders our stuff? Where do they order it from? How do they order it? And you come up with some values in a spreadsheet that the users look at that trigger conversations. Oh, we have to have discounts in different types of dollars, different monetary units, different percentages. We have to be able to sell to people, businesses, and government agencies. We don't have exact order dates. We don't have discounts on some, right? So by talking with our users and coming up with what's called a BEAM table, business entity attribute model, we can then go on and create an event matrix that shows us what our business does, who's involved in doing it, what they do, where they do it, and why and how. And once we build our event matrix, we can then go on to creating our dimensions, our processes, and a star schema. I can hear you saying, oh my God, Leslie, there's no way anybody at my work's going to let me do this. You're right. So there are some easier ways that you could do that. You can start on a whiteboard. You can pick one thing. Again, I worked at the police department. We have a call for service. Someone calls 911. Who does that? Where does it happen? What type of thing? What type of call type? How was the officer disposed? What unit went? What priority was the call? Right? So it doesn't have to be a big thing. It could just be a whiteboard. You don't even have to go any further than that. This would get you enough to identify a small set of data that you could bring in and build a proof of concept off of one event in your organization. Another technique is some document templates like this from Genesee Academy. This is Hans Heltgren. You define a core business activity, and then again, talk with your users, define it. In this particular situation, I've said a call from a citizen to 911 that results in a record being recorded in the computer-aided dispatch system. And sometimes very specific definitions like that are required because there are other reasons that records get inserted into the computer-aided dispatch system that we may not want to count as a call for service. We add the AKA, also known as, in there, because some people within the organization call it a CAD and some people call it an incident. So we put those things in there so that when we're talking about it, we can say, oh, a call for service or a CAD or an incident. Identify which attributes you want to know about that activity: the number, the priority, when it was created, when it was dispatched, when they arrived, when they closed it, how long they sat on hold, right? There's one of our measures. You classify those attributes into a date, time, a measure, a classification, a status or a state, or a reference or an ID. So there are lots of different ways that you can collect the information that you need in order to start to build some structure around the data that you're collecting and how you're using it. Here are some links to both of those websites so that you can go and find out some more about both of those techniques. And why is that important? Well, because like I said, most of us can't go back to our organizations and create an entire data warehouse or build something from scratch, but you don't have to. You can do it all in Power BI. And like I said before, Star schema is how Power BI likes to have your data. So if we look at what Microsoft said, this was in September of 2019, Microsoft published this in their Power BI guidance documentation that it likes to have star schemas. Dimension tables support filtering and grouping, and fact tables support summarization. So I know you're probably all real familiar with this. Standard Power BI. I'm going to walk through and show you how you can take advantage of building your star schema within Power BI. We're going to get some data. First thing I'd like to show you is all the different types of data that you can pull into Power BI. We have the Power Platform, and I'm sure since I took this snapshot many moons ago that this has increased. We have Azure data sources that you can connect to and build reports off of. In this particular example, we're going to pull in a text file that I've created. We're going to push the connect button. This is a sales file that I created out of the AdventureWorks data warehouse. And it's a standard comma delimited file that has information about the products and the sales that we have and descriptions and where it was sold, the sales territory key. We're going to select the transform data. I believe this is a default now to transform the data before you load it. And we're going to come in here and we're going to use the Power Query Editor, which we can tell because up in the top left, we have Power Query Editor as the tab. And we're going to take our sales file and we're going to split it up. We're going to take all of the information about the sale and we're going to keep it in a fact table. And then we're going to duplicate that and create two different files with the product dimension and the territory dimension. So I've struck out, removed the other columns, and all I'm left with is the sales territory key, the region, and the group, and the alternate key. And I did the same thing with the product. I have the product key and the product information. So then when we go back into our sales, we keep the product key and the sales territory key, and we get rid of all of the rest. So now we have a star schema, and we're going to push the close and apply button. And that's going to take us back to the Power BI desktop. And we want to go right here to the little modeling tool. And it goes ahead and it creates the relationships for us between the tables. So we have our sales table in the middle with our product key linked to our product dimension and our territory key linked to our territory dimension. Then we can go to the report page. We can click on a visualization, a bar chart. We can tell it we want to include the sales amount and the sales territory group, and we can push a button and get a graph. But here's the thing. Anyone can put some data into a graphing application and create a graph. This is remarkable considering that the process of creating a graph was historically reserved for scientists or those in other highly technical roles. So think about that. 200 years ago when you had to draw the graphs by hand, who did that? Very skilled people writing in ink because you only got one chance. Now, you throw it into Excel, push a button, and you have a graph. So Cole Knaflick is owns Storytelling with Data. She used to work on the Google People Analytics team before she went out on her own. She's created this book, Storytelling with Data. And some of the things that she talks about in this book is that out of the 150 visualizations that she's created for clients, she only uses about 12 different types of graphic information tool. Simple text, scatter plot, table or a heat map, which is really just a special kind of table, a line graph, slope graphs, bar graphs. I know we all hate bar graphs, but they work, waterfall, and an area graph. You'll notice what's not on here. Pie chart. Pie charts are horrible. So I want you to look at this. Which one do you think is bigger, A or B? Which one has the bigger supply of market share? We don't know because they didn't add anything to give us that. And our eyes can't detect it. Our eyes aren't built to be able to see that. If we look at it, A actually is the larger one, even though it kind of looks like B is. And the reason for that is because that tilt makes the top appear smaller. And the 3D makes it hard to read. And pie charts in general are hard. If you have more than 2 values, you really shouldn't be using a pie chart. If it's binary, yes, no, male, female, I'm sorry, I shouldn't say that because that's not a binary thing. We'll edit that out, fingers crossed. So if you have 2 values, then that's the time that you could use a pie chart. Bar graph is a much better way to show that information and be able to actually see which one is bigger. And the reason for that is because of the Gestalt principles of visual perception. In the, I forget when it was, in the early 1900s, at the Gestalt School of Psychology, they did some tests to try and determine how people perceive the world and came up with these principles: proximity, similarity, enclosure, closure, continuity, and connection. And here are a couple of ways that we can use these visual perceptions to draw people's eyes to the information that we are trying to show. So here we have proximity. These things must mean something to the things around them because they're close to each other. These things are arranged in such a way that one looks horizontal and one looks vertical. They're exactly the same, but just because of the spacing and the proximity and how they're lined up, they look different. Again, with similarity, the orange ones, they must mean something because they have a color that's connecting them to those other things. Enclosures, right? If we group these things together, even though they're distant, because they're grouped, they belong together. We can point out these ones in the middle are important to us by putting a box around them and drawing the user's eye to that section. Our brain also has preattentive attributes. There are things that the size, the color, and position of something that you don't have to think about to know. Your brain just knows. So if we look at this, how many 3s are in this graphic? It's really hard to tell. You have to look at each line. Some of you might be, pretty quick at, oh, I can find patterns pretty quickly and find those. But for some people, that's a very difficult thing to do. However, if all you do is bold it, if you just change the size or the color just a little bit so that those pop out, it's really easy to see now that there are 2, 4, 6 3s. Some of the other things that our eyes just see: orientation. You don't have to think about which one is slanted. Color. You don't have to think about which one's a different color. It pops out at you, especially a color like red. Width. We can see that one is wider than the other. Same thing with length. So these are things that we can use when we're building reports that allow us to draw the user's eyes to the information that we're interested in seeing. So if we just draw a graph from the top 10 design concerns about a car, concerns per 1,000 people, well, we can see that the engine power is less than expected is the biggest concern. But if we dig down a little bit more, maybe what we want to know is how many have 10 or more concerns per 1,000 people, right? So we really don't care too much about the last 3 because only 8 concerns per 1,000. We've cut off a threshold of 10. And then when we dig down further into these, 3 of those are noise related. And now we've used color to put forth, these are the 3 that we want. And we've used a little comment over to the side. Now, again, this is data storytelling. This is not a report. This is when you are trying to put together a presentation to prove a point or get somebody to pay attention to these things, right? You are trying to tell a story with this and you're using these things. This isn't just, building a dashboard. Just so that we're clear, this is a different type of presentation of data. So some of resources for Power BI and data visualization. The understanding for the star schema is one of the Microsoft Docs. Guy in a Cube, usually when I'm doing this live, I'll say, hey, how many of you guys listen to Guy in a Cube? And I go, yo, and they all stare at me blindly. I'm like, really? So hopefully you guys are going to go out there and watch Guy in a Cube because Patrick and Adam are awesome. Radicad is ResiCAD's website. He also is a Power BI guru. And of course, Cole Knaflick, Storytelling with Data. I also want to take a second here to talk a little bit about accessibility and reports. Megan Longoria is out on Twitter. She is a big proponent of accessibility and has this blog post that she did where she goes into great detail about why you should build reports that are accessible, not because you need to make them accessible, but because it makes it easier for everyone to use them when reports are accessible. So go follow Megan. So if we go back to the beginning and we look at our the AI hierarchy of needs, the only thing that I would say could be an improvement on this is that it needs to be based on data governance. And all of these aspects of data science need to be surrounded by that data governance. So what is data governance? It is the practices and processes which help ensure formal management of data assets, because that's the thing, data is an asset. We need to make sure that we are treating it as something that's important. We need to keep it safe. We have to understand things about data stewardship, data quality. We have to help the enterprise gain better control over those assets, including methods, technologies, and behaviors. It is insane to think of the number of databases that are out there that have your social security number in them that you don't even know of. And you would hope that as a data professional, it would say something like person ID, just to little bit mask that, you know, that this is a security breach. But no, there are databases out there and it says social security number as the name of the field. So as an organization, having data governance and understanding of how your data is used and what you're storing, key in keeping that data safe. Security and privacy, integrity, and integration compliance. Maybe you're subject to GDPR, maybe you've got HIPAA, maybe you have SEC compliance that you have to worry about. There are all sorts of issues around data compliance and security that if you don't have a strong data governance system in place, that it may end up costing you money and legal battles. So where do you start with data governance? Again, another big can of worms. First, you have to discover your data. You have to know what the data is, the business rules. Do you have any existing governance policies? Have you identified any key performance indicators for your organization that you have to make sure that you have that data in order to do that analysis? You have to be able to automate those rules, document the workflow, have collaboration between business and not just IT. That IT picture should be your data science team. And it's a collaboration between everybody within your organization to make sure that we keep the data safe, that we're collecting it, that we have policies around where it's stored, how it's stored, who accesses it. And then we have to make sure that our data governance is working. So the measure and monitor is not of the data, it's of the governance. Do you have data lineage analysis? What do you do to make sure that you are continually improving your data governance processes? What ROI are you getting out of that governance? And can you specifically identify those things that you've made better? Again, there's already some frameworks out there. This is from Robert Seiner and KIK Consulting. They specialize in a non-invasive data governance framework. They have tasks and roles at different levels of the organization, whether they're operational, executive. We have the processes, the communications, the metrics, and the tools, and who's assigned to do what types of things. He has some other templates that allow you to document your data, who owns it, who's responsible for the changes, what business areas, They're all also color coordinated back to that other slide so that you can make sure that everybody is doing the work that they're supposed to do. So to recap, we discussed the AI hierarchy of needs. We went over the foundational activities of the building within your organization, the basics of data modeling, some visualization techniques and how to use reports and the built-in systems in our brain to actually draw people's eyes and get the information across that you're interested in doing, and data governance, how we make sure that the data that we have collected is safe, that we're using it in appropriate ways. We talked about assembling a team. Who are those people though? We have to have a chief data officer. You really need somebody at the top levels of the organization that is going to be your champion, your cheerleader, that sits at the C-suite with your CEO and your CIO, that has an understanding of the data and the flow. Maybe they're not called a chief data officer at your organization, but you need to find somebody at the top level that's going to be your cheerleader, your bulldozer, somebody that's going to go to bat for everything that you need to do. You have to have people building the architecture. You have to have the collection from the systems that you have, whether those are transactional, Internet of Things, using Databricks, Data Factory, all of the cloud services that are available to migrate and do all of this work in a streamlined way and in a way that's easy to do proof of concepts, because you go up to the cloud and you do a little thing and then you build on that, and you can see the benefit of moving it up to the cloud, doing your ETLs through the ADF and Databricks. You have to have people inside your organization that are the subject matter experts. They have to know those processes. How do you get the data in every day? What processes do your users use at the very front line when they're collecting that information? What workarounds do they do on their everyday to-day basis to get around limitations of your operational software? We all know those people that, oh, well, there's this one thing and it doesn't have the right stuff, so we always put X over here, and then we go over to the note system and we type in what we really mean, right? It's capturing all of those workarounds so that you get, oh, if it's X over here, that means we have to go look in this other place to get what really happened. The reporting requirements, not necessarily to duplicate what's currently happening in the reports, but to find out what questions do your upper management and your users have about the work that they can't get answered now. What can you do to make it so that it's easier for them to do their jobs, that they don't have to spend 90% of their time cleaning the data and prepping the data and creating spreadsheets and doing all of this stuff, to spend 10% of their time doing their actual jobs. The visualizations and the report writers, getting those people in there that know how to build beautiful things. I'd love to build beautiful reports, but I don't. Most of them are, you know, boxes with numbers and bar charts, and I go out and look at some of the Power BI reports that you can download and the dashboards that have been built, and I'm just continually amazed by the creativity that people have when putting something together that is insightful and meaningful and useful to their users without having them work hard to get to that. And the last thing that we have to do is we have to make sure that within our organization, we are always talking about how this data is an investment. It's an investment in the time and the resources. And if you go out and Google, I don't know, I think it was a couple of weeks ago, there was some article about the airline industry, and they're struggling so hard now, but they have been able to leverage the data from their customer loyalty programs to the tune of like tens of billions of or millions of dollars. I mean, they are able to get all sorts of information out of those customer loyalty programs. And it's just a matter of being able to identify what that information is that's in there that you want. You have to have those data scientists, those people that can just build those algorithms and find those anomalies and identify those things that are what you want to know. And that's a skill too. And to find one or two people to put all of this work on in an organization. A lot of organizations, we don't have the money, we don't have the people. It's true. But at the same time, if you want to be able to leverage the data and be able to gain those competitive advantages, you have to be willing to invest in your people, your resources, the tools, the collection, and build something that helps you really understand the value of the data so that you can make decisions that will ultimately make more money for everybody, because that's really what most business people are after. Are there any questions?
I don't really see any questions, Leslie.
Okay.
If you guys, I don't know if you guys see any on your end, but if you guys don't, because I know it's, oh, you did good timing.
All right, well, I just wanted to finish up with saying that if you do have any questions or would like some follow-up information about being able to embrace some of these concepts within your organization, please feel free to reach out to our sales team. We are here for Azure server migrations, database migrations, Databricks, managed services, Power BI expertise, and are willing and able to come in and help you take advantage of some of things. I appreciate you joining me again. Follow me on Twitter or LinkedIn, and we'll see you at the next webinar.
All right. Thanks so much, Leslie. And like Leslie said, please feel free to reach out to her and myself if you guys have any questions. As I stated earlier on, you guys will receive an email link for the recording tomorrow in your email box around noon Eastern Standard Time, as well as this will be on our YouTube channel, so you guys can view it there too. It's usually up maybe an hour or so before, so if you guys want to log on there. But I hope you guys have a good rest of your Tuesday. Sorry for all the technical difficulties. We thank you so much for joining again, Leslie. Thank you so much for hosting. You guys have a wonderful day, afternoon, or evening.
Thank you. Bye. Bye.